Let's try a slightly more complicated example. So you want to take the limit as x approaches 1 of 1 over ln of x minus 1 over x minus 1. Now, first we need to check to see if L'Hopital's rule will even work. So, let's try just direct substitute. So, this should equal 1 over ln of 1 minus 1 over 1 minus 1. Well, ln of 1, what's that? Well, that's basically, what do we raise e to get 1? Well, anything raised to 0 equals 1, so we must have to raise e to 0 to get 1. So ln of 1 must be 0. So 1 over ln of 1 is 1 over 0. Minus 1 over 1 minus 1, well, that's 0. And 1 over 0 isn't a number, but it is a limit. And that limit is infinity. So 1 over 0 minus 1 over 0, that's infinity. So we have infinity minus infinity. While that's not one of our primary indeterminate forms, we do know that that's one of our secondary indeterminate forms. So let's try and do some kind of manipulation to try get this argument to come out with a indeterminate form of 0 over 0 or infinity over infinity. So let's take our argument 1 over ln of x minus 1 over x minus 1. So let's try combine them into a single rational function. So we'll do that by adding or subtracting them, but to do that first we have to make sure they have common denominators. So let's multiply this part by ln of x over ln of x, and we can because ln of x over ln of x is 1, and we'll multiply this one by x minus 1 over x minus 1, right? X minus 1 over x minus 1. So we'll get x minus 1 over ln of x, x minus 1, minus 1 times ln of x, which is ln of x, over ln of x, x minus 1. So we can combine those now. So it looks like x minus 1 minus ln of x, x minus 1 minus ln of x, and that's all over. Well, instead of saying ln of x times x minus 1, let's multiply this in. So we'll get x ln of x minus ln of x. So instead of taking the derivative of that, we're going to try and take the limit of that. We're going to try to take the limit of this. So take the limit as x approaches 1. So we'll do direct substitution, and 1 for every x. So 1 minus 1 minus ln of 1 all over 1 times ln of 1 minus ln of 1. So that's 1 minus 1, that's 0, minus ln of 1, that's 0 too, over 1 times ln of 1. Well, ln of 1 is 0, so 1 times 0 is 0, minus ln of 1, that's 0 again. So we get 0 over 0, which is indeterminate, which is good. So now we can do L'Hopital's rule. So let's try. So we'll take the limit as x approaches 1 of the derivative of our top, x minus 1 minus ln of x, take the derivative, put that over the derivative of x ln of x minus ln of x. So let's see, the derivative of that would, so it'd be the same limit as the same x approaches the same 1. Now the derivative of x, well, that's 1. Derivative of negative 1 is 0. So, and then the derivative of negative ln of x, that's negative 1 over x, right? And then let's try, and then we want the derivative of x ln of x. Well, that's product rule, right? So x ln of x, derivative of that is equal to x prime ln of x plus x ln of x prime. So x prime, well that's 1, so ln of x plus x times ln of x prime, which is plus x times 1 over x. Well, x times 1 over x, that's just 1. So ln of x plus 1 is the derivative of x ln of x. So we should get ln of x plus 1 minus the derivative of ln of x, which is 1 over x, right? So let's try our direct substitution again to see, okay, we've taken the derivative of the top and the bottom, we should be able to get our limit now in a non-indeterminate form. So that equals, hopefully, 1 minus 1 over 1 all over ln of 1 plus 1 plus, well, 1 over 1, sorry, this should be minus. It's minus, it was negative ln of x, so it should be minus 1 over x. So minus 1 over 1. Now that equals 1 minus 1 over 1. Well, 1 over 1 is 1, so 1 minus 1 is 0. And we'll have ln of 1, which is 0, plus 1, minus 1. Wait a minute. 0 over plus 1 minus 1, that's 0. So 0 plus 0 is 0. Wait. We have an indeterminate form again. Indeterminate form. What does that mean? Well, it doesn't necessarily mean that we did anything wrong or that we did anything inconclusive. That just means, well, we're taking the limit of something, we get an indeterminate form. What do? You apply L'Hopital's rule. There's no limit to how many times you can apply L'Hopital's rule to a function. So let's take the derivative again and try to see if we get, let's try reapply L'Hopital's rule and see if we can get a better limit than just 0 over 0. So let's take our limit of our already L'Hopital argument. So we'll have the limit as x approaches 1 of, instead of just trying to take the derivative of this, because the derivative of 1 over x, while it's simple, it's kind of a pain, let's try and multiply everything through by x over x and do a little bit of argument manipulation to make it easier. And we can do that because, well, we're multiplying by 1, and you can do that whenever you want. So we'll have x minus 1 over x times x is 1 all over x ln of x plus x negative 1 over x times x, that's minus 1. Alright, so let's try to take the limit of that and see where that gets us. So we tried to substitute 1 in, and we know we won't do anything, so let's try reapply L'Hopital's rule and take the derivative of our top and then put it over the derivative of our bottom. And so it'll be the same limit as the same x approaches the same 1 of derivative of x is 1 and derivative of negative 1, well, that's just 0. And derivative of x ln of x, we already figured out that was ln of x plus 1. So that's that. Plus 1, because the derivative of x is 1. And this becomes 0, because the derivative of a constant is 0. So now, this looks a little more promising. Let's try do direct substitution. So this should equal, hopefully, a number, or at least a better limit. So x, so should be 1 over ln of 1 plus 1 plus 1. And so that's 1 over ln of 1, well that's 0, plus 1 plus 1. So that's 1 over 0 plus 1 plus 1 is 2. So 1 over 2. So we now know that I limit up here as x approaches 1 of 1 over ln of x minus 1. If we try to do direct substitution, we get an indeterminate form. So we do some argument manipulation, we apply L'Hopital's rule, and we get another indeterminate form. So then we apply L'Hopital's rule again, and then get a non-indeterminate form and get a good limit of 1/2. So now you should be able to apply L'Hopital's rule to whatever you need with full confidence and full knowledge of how.
I'm Daniel Cheta. I'm a math teacher here at King Kekaulike High School. Basically, for me, I think math is same no matter what, in high school or in college. The math that you learn in high school basically takes you to higher order, math topics. So math is the same everywhere. So I think it just helps me prepare for the higher order thinking skills that you need in college, basically. So.